Now that we've covered a lot of the main concepts of functional programming, we've looked at function composition, I want to take some time and talk about recursion, or a recursive function. Now what this means is essentially a function that can call itself, and why and how it calls itself is what we're going to learn in this video. Now recursion is typically used for iterating over perhaps an operation using a function that repeatedly calls itself until it gives you a final result. So you can actually kind of think of this as a kind of loop that we can replace with a recursive function. And this is not unique to JavaScript. Recursion exists in many other functional programming languages as well. Recursion is typically used when we need to call the same function repeatedly and we want to, for example, pass different parameters into the function each time. This could be iterating down branches of perhaps a data structure for sorting data structures, or perhaps some kind of math operations. Finally, as with many things in functional programming, recursive functions are pure functions, so they're very easy to use and write as well. Now, what I want to do is demonstrate to you something called a factorial. Now, a factorial, we're going to demonstrate how we can use a recursive function or recursion to essentially replace a for loop in JavaScript, which when we're dealing with functional programming, we want to try and stay away from the more imperative and older style with expressions and statements and stick to functions. So if you're used to perhaps using a for loop to perform recursive operations, it might be that we can now adopt a functional programming style and use a recursive function. So what we are in fact going to do is calculate the factorial of a number. Now, for example, if you haven't heard of a factorial, we could take, for example, a factorial of 3. To calculate the factorial, we can simply say 3 times 2 times 1 equals 6. Because we have 3 multiplied by 2 is 6 times 1 is 6. If we were to have the factorial of 5, this would be 5 multiplied by 4 multiplied by 3, multiplied by 2, and finally multiplied by 1. So what we can do to arrive to this is 5 times 4, 5, 10, 15, 20, multiplied by 3 is 60, multiplied by 2 is 120, times 1 is 120. So a factorial essentially takes a number, could be 3, and the way that we can arrive at the factorial is to minus 1 every single time and multiply it by itself minus 1, essentially. Now this could be achieved via a loop, and it also could be achieved via recursion. Now first off, we're going to create a factorial constant, and we can assign it a function that takes a number. Now inside the function, we are going to have a let statement with a result. We can give this a value of 1. Now at the end of the function, we're going to return the result. Now if the result does not meet the intended parameters, if it is not greater than 1, we're going to return the original result of 1. Otherwise, we're going to modify it inside our for loop. So what we're going to do inside of here is quickly say let count, and we're going to cache the parameter, the argument given to us in the function. We can then check if the count is greater than 1. Then we want to simply go ahead and decrement our count variable. So what this will then do is for each iteration, if we were to call the factorial, for example, with a number 6, this would then run the code and minus 1 by decrementing that count every single time, at which point we can update our result with the result multiplied, because obviously we need to use multiplication, the count that we've passed in. And don't forget that we are in fact decrementing the count every single time. So if we were to console log our factorial, print it out in the console, we can see that we have 720. We can confirm if we use a number 5, we can see that we have 120, and also the number 3 will give us 6. So this is in fact how we could use a loop to calculate the factorial of a number. And again, we could do something like this and say 3, 6, and 9, and you can see how this exponentially gets a lot bigger. So that's one way that we can do things with a traditional for loop style. However, we're dealing with functional programming a little bit more in this chapter. So let's go ahead and create a new factorial, which definitely takes the number again. However, this time we're just going to return something different. So this can be nice and simple. Now, because we need to keep a result of 1, if the number is not greater than 1, we can simply say if our number is greater than 1, then what we can do is return a calculated number multiplied by the factorial. So what we're going to do is actually call the function from inside itself. Now we'll leave that there for a moment. Otherwise, what we're going to do is simply return the number 1. So our return number 1 is going to cover the edge case that we are in fact passing in a number 1. Otherwise, if our number is greater than 1, it's going to return us that particular number multiplied by the factorial function, which we're going to take the number and all we're going to do is minus 1 from it. So every single time this gets called, this is going to give us the exact same numbers. But every time this gets called, it's actually going to call itself until it gets down to the end of the numbers. So for example, if we go ahead and say console log n, we'll save this out and you can see a lot of numbers in the console. So here we have our factorial of 3. You can see that our line 15 is being called with 3 multiplied by 2 multiplied by 1. So every single time we're taking that number, decrementing it, or just minusing 1. Now what's nice about using recursion here is that we do not have to maintain any kind of state. We are simply using a pure function, and here we're just using a small expression just to minus 1. Whereas up here we were mutating values and keeping track of where we are in a loop. Whereas with functional programming, we don't really need to do this. Now we could also neaten this up quite substantially if we wanted to. We could drop our arrow function altogether. It's up to you if you want to copy this as I'm doing so. And once we're finished, it gives us a really nice one-line lambda expression. And then we can complete our ternary statement. So we can save that out, and that gives us the exact same behavior as before. Again, this is a nice pure function, just some simple recursion by calling the function from within inside itself. And what's also great here is because we are using an ES6 arrow function, we can create a nice one-line lambda style expression. We don't need to deal with the this keyword. We can access the factorial function by its name and then simply invoke itself. So I think that's a really nice example of recursion. Recursion will be far better and faster at calculating different problems and gives you a slightly cleaner solution than using a loop.